Hi students, in the previous classes we have discussed about few classifications of elements. That is, we have discussed about Dobonier's classification as well as Newland's classification. And now in this class we are going to discuss about another type of classification, that is Mendeleev's classification. So Mendeleev is a Siberian chemist. So he classified elements on the basis of the atomic weights of elements. He arranged all elements in the ascending order of their atomic weights or atomic masses. So let us try to understand some salient features of Mendeleev's classification. So first one, groups and subgroups. According to Mendeleev, he classified all elements into 8 groups. What is a group? A group is a vertical column. So all vertical columns are called as groups. So Mendeleev classified elements into 8 groups. Again, each group is classified into 2 subgroups, that is A and B. That means every group has been classified into 2 subgroups A and B. So on what basis he classified these subgroups? So according to Mendeleev, the elements present in each subgroup have similar chemical properties. That means if we take the first group again classified into 1A and 1B. So 1A and 1B, these two are subgroups in first group. In 1A, the elements present are lithium, sodium, potassium. See, according to Mendeleev, all 1A group elements have similar properties. So same like that, 8 groups have been divided into 2 subgroups. That means A and B. And the second one, periods. What is a period? A period is a horizontal row. That means the elements have been arranged in some horizontal rows. How many rows are there according to Mendeleev? There are 7 rows. That means 7 periods in the Mendeleev's classification. So according to Mendeleev, there are 8 groups and 7 periods. And the next one, the third one. So after discussing about groups and periods, we next discuss into the next important point, that is he predicted few elements which were not known at the time. That means prediction of new elements. So while arranging elements into groups and periods, so he left some places for newly discovered elements, because he predicted some new elements with their chemical properties. So that means, so when he classified the elements at that time, only few elements were known to him, but new elements were discovered after this Mendeleev's classification. So that new elements he predicted at that time itself. Mr. Mendeleev left few places for the newly discovered elements. That means at the time of his classification, few elements were not discovered. So that's why he predicted few elements which were unknown at that time. And also he predicted the chemical properties of that new elements. So like that, he predicted 3 elements which were not known at that time. So he named that 3 elements as Ica boron, Ica aluminium and Ica silicon. Here Ica, this word was taken from Sanskrit. So after the prediction of this Mendeleev, that means after the classification of Mendeleev, these 3 elements were discovered by few scientists, and the chemical properties which were predicted by the Mendeleev was these three elements, chemical properties were mostly similar to the newly discovered elements. That means these Ika boron, which was predicted by Mendeleev, is named as scandium, and Ika aluminium, which was predicted by Mendeleev, is named as gallium, and Ika silicon is named as germanium. That means scandium, gallium and germanium. These three elements were not known when Mendeleev classified elements, but he predicted these properties of these three elements. But unknowingly, after classification of elements, so these three elements were discovered by the scientists, just similar to the chemical properties predicted by Mr. Mendeleev. And the next feature of this Mendeleev's classification is he corrected some atomic weights of elements. That means at the time of classification of Mendeleev, the atomic weights of few elements were wrongly calculated. So by his knowledge, he corrected the atomic weights of a few elements. And let us try to learn the limitations of Mendeleev's classification. So mostly the classification of Mendeleev is almost accurate. Only few limitations are there in this classification, and the first one is anomalous pair of elements. That means actually the principle of classification of Mendeleev is he classified all elements on the basis of ascending order of atomic weights of elements. That means the atom, the element which has a low atomic weight should be placed first, and the element which has a higher atomic weight should be placed next. But in the case of tellurium and iodine, there was a small mistake done by Mr. Mendeleev. Actually, the atomic weight of tellurium is 127.6 and the atomic weight of iodine is 126.9. So actually in these two, iodine has a lower atomic mass. That's why iodine has to place first. But unknowingly, Mr. Mendeleev placed tellurium first and then iodine next. And the second limitation is in the arrangement of elements. Some places of the periodic table, he placed dissimilar elements together. That means, actually, according to Mendeleev, the elements having similar properties were placed in the same subgroup. But in few groups, he placed dissimilar elements in the same group. So these are the very minor limitations of this Mendeleev's classification. By the overall, this Mendeleev's classification has given more information about the classification of elements, and this Mendeleev's classification has become the backbone for the modern periodic table. So in the next class we discuss about the modern periodic table, which is most important in the chemistry.